Hey guys, in this video we're going to be talking about 7.3 and 7.4 in the textbook. And basically both of these sections involve integration and different techniques of integrating complicated functions. So the first thing we're going to talk about is 7.3 tables of integrals. And for this section you are going to need a table of integrals. It's going to be found in the ebook under Ready Reference, or it's going to be where you found this video under the video page. You should see the table of integrals there. So I would definitely put that off to the side and look at it while we're doing these examples, because I'm going to be using that for all of these pretty much. Okay, so the first example, we want to find the integral of sine 7z times sine 3z dz. And so if you look at your table, you want to see which one of these matches the closest to what we have. And it turns out that numeral 2, number 10 in the table matches this perfectly. And this is what it says. It says that we have an integral sine of ax times sine of bx dx. Well, that's equal to 1 over b squared minus a squared times a cosine ax sine of bx minus b sine of ax cosine bx. And of course, since it's indefinite, plus c. So this is numeral 2, number 10 in the table. And I knew to use this one because this guy and this guy are just numbers, right? And so in this case, our a is equal to 7 and our b is equal to 3. Those are numbers in front of our variable, which is not x, but it's z. We're integrating with respect to z. So that's how I knew to use this formula, because it matches up perfectly with this. A is 7, b is 3. Okay, so now I just have to plug in the information. So we just said that a is 7, b is 3. So using the formula over here, we get the following. Squared minus 7 squared. And our variable is z instead of x. Let's just keep that in mind. Okay, and there's our answer. I could simplify the fraction if I wanted to negative 1 over 40 in the front. So let's just do that really quick. And that is the gist of that example. So we're just using this table to find the closest match and then apply the rule. All right, let's try this one. I encourage you to pause the video and see if you can look through the table and identify the rule that's going to get, let us evaluate this integral, basically. All right, so here's the rule that we're using from the table. We are using numeral 3, number 14 in the table. And what does that tell us? That tells us that a polynomial p of x, remember what a polynomial is, it's just basically it's a function that's not rational or transcendental. So x squared plus 3x minus 4, something like that. Polynomials. E to the ax dx is equal to, okay, and then we have this rule. We have, and I'm looking at the second line, 1 over a p of x e to the ax minus 1 over a squared p prime of x e to the ax plus 1 over blah 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 p double prime x e to the ax minus dot 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 and in parentheses, the signs alternate. Okay, so let's interpret this a little bit. So how did I know to use this rule, numeral 3, number 14? How did I know? Well, look what I have here. I have e to the something x, where the something is a, that number that's being multiplied by x. So that's this piece. I have that piece. And the other piece is the polynomial that's being multiplied by it. So p of x is just this whole thing, this whole polynomial that's being multiplied by it. Okay, so that's how I knew to use that rule, numeral 3, number 14. Now let's go ahead and apply it to the right side of the formula. So we know what a is. In this case, a is 3. That's the thing being multiplied by x in our formula. So a is 3. And p of x is, maybe I'll do that in yellow actually. My polynomial is going to be x to the 5th plus 2x to the 3rd minus 8. All right, so let's go ahead and follow the formula. The first part, I have this. So 1 over a, which is 1 over 3, times p of x, which is that polynomial, times e to the ax. Oops. E to the 3x. All right, so that's the first part. Now let's look at the second part. Let's do it in red. Minus, okay, 1 over a squared times p prime of x. What's p prime of x? Well, I just have to use the power rule. Remember that thing? 5x to the 4th plus 6x squared. I'm just taking the derivative. All right, so let's write that down here. Power rule. Okay, again, times e to the ax, so e to the 3x, and we keep going like this. And what's happening is eventually, we keep taking derivatives, and eventually the derivatives are going to just keep, we're just going to have 0, basically. Okay, so let's keep going with this. Now the signs alternate, so the next one I'll do in green. Let's do this plus. So let's do plus 1 over a cubed p double prime. We take the derivative again. So the derivative of 5x to the 4th plus 6x squared using the power rule is 20x to the 3rd plus 12x. Put that in parentheses. And again, times e to the ax, e to the 3x. All right, so signs alternate, and we keep going in this pattern. So the next sign, since I finished with a positive, I go negative now. And again, I have 1. Instead of a to the 3rd, I'm doing a to the 4th next. That's what comes next in the pattern. All right. Now the next one is p triple prime, like we're taking the derivative again. So when I do that, take the derivative of 20x to the 3rd plus 12x, I get, what do I get? 60x squared plus 12. And of course, tack on the e to the 3x. All right, what comes next in the pattern? A plus. The signs alternate. 1 over 3 to the 5th. We're going up every time we do that. 4th derivative. Crazy. All right, so derivative of 60x squared plus 12, we get 120x. Tack on the e to the 3x. This problem's kind of wild. Okay, next sign is minus. We're alternating signs over 1 to the 3 to the 6th. Derivative of 120x, this is 5, 3, 4, 5, is going to just be 120. And now we can breathe a sigh of relief, because if we were to continue the pattern and we did plus and then took the derivative of that, we would end up getting 0, right? So we are done. We are done here. Let's just go ahead and that's a crazy answer. There it is. That's our answer, you guys. Now you can simplify the fractions, of course, but me being the type of lazy person I am, I'm just going to leave it like that. So that is my answer for that one. Awesome. All right. So we want to integrate 1 over the square root of 25 minus 16x squared. Now I encourage you to pause the video, look at your table, and see which of these rules you're going to use. And it turns out that here we are going to use 6/28. So numeral 6, number 28. Now here's a question to ponder. Why not use 29? Well, let's look at what 28 says. 28 says the following. It says 1 over a squared minus x squared dx is equal to inverse sine or arc sine of x over a plus c. Okay, so that's number 28. Now, if you look at 29, it's kind of the same thing, but reversed. We have x squared in the front instead of the a squared under the radical. X squared plus or minus a squared on the bottom. Why I use this one is because if we look at our problem, a is going to be a constant number, whereas this x squared is, we're going to have a variable involved. So since the variable comes second, I chose to use 28 rather than 29. Okay, great. So now what we need to do is we need to make our problem look like the formula that we have here. So what I can do, I don't have just a single, sorry about that. I don't have a single variable squared here, but that is what I want, right? So I need to do a substitution in order to use this formula, right? So what I'm going to do is I'm going to introduce a new variable. You can use u like we've been doing, or you can do w. I'm just going to do, let's do w just for fun. So let w equal what? Equal what? All right. What we want is, we know that a squared, this first piece, has to equal 25. A squared equals 25. And x squared, or w squared in this case, has to equal 16x squared. All right? So if I take the square root here, a is going to equal 5, and over here, when I take the square root of 16x squared, w is going to equal 4x, right? So w is equal to 4x. So let's write that over here. W equals 4x. And, okay, so let's go ahead and rewrite our problem with that information. So we have 1 over the square root of 5 squared minus w squared dx. I just brought the dx to the side instead of being right on top. Now, what I need to do is I want to integrate this with respect to w, so I have to figure out what dx is. And to do that, remember, we take the derivative of both sides, so dw is equal to 4 dx. Divide both sides by 4 to give me dx is equal to dw over 4, or 1/4 dw equals dx. Okay, so let's go ahead and replace that in our problem. We have 1 over the square root of 5 squared minus w squared. Instead of dx, we want to integrate with respect to w, so we have 1 over 4 dw that we replace dx with. Okay, now I can pull out that 1 over 4. It's a constant. And now I'm in the correct form, right? I have my a squared on the bottom, just like in the formula here. I have 5 squared on the bottom. Then I have x squared on the bottom, which our variable is not x in this case, but it's w. So now I can just use the right side of the formula. It equals arc sine of w over 5 plus c. So this is equal to a fourth. And then we have arc sine of w over 5 plus c. Last thing to do is sub back in what w was. W was 4x. So my final answer here is a fourth times arc sine 4x over 5 plus c. And that is my final answer there. All right, so now we have the integral of x to the third sine of x squared dx. So the first thing we need to do is find an appropriate formula from our integral table. So pause the video, see if you can do that. What I'm using here is numeral 3.15. And that tells me the following. The polynomial p of x times sine of ax dx is equal to negative 1 over a p of x cosine ax plus 1 over a squared p prime of x sine of ax plus 1 over a cubed p double prime x cosine Okay, so that is what we have here. So in this case, what do we have? We have a polynomial times a sine function. So in this case, p of x is going to equal x to the third. And we need to make a substitution because what the formula tells us is the sine of ax, where a is a number. But we don't have that. We have the sine of x squared. So we need to go ahead and do a substitution here, a variable substitution, and say let w equal x squared. Then dw is equal to 2x dx. And now we can go ahead and substitute that stuff in. So our original function, we have x to the third sine of x squared dx. And when I make my substitutions, well, dx is equal to dw over 2x. So this is my info that I'm subbing in. So my original problem becomes x to the third sine of w and then instead of dx, we have dw over 2x. Now what's nice is we have a cancellation of an x there and then one here. So what we get is we get x squared sine of w dw. Well, now we want to integrate with respect to w. So can we turn x squared into terms of w? Well, yeah, because originally we called x squared w. So I'm just going to replace that there with w. So this is W. Sine of W dW. Okay. Oh, I forgot the 1 over 2. That's what I forgot. Okay, so at this step right here, we need to bring a 1 over 2 out. So let's carry that down here. Okay, so now I'm just going to use my formula right here. Now, in this case, a is the coefficient being multiplied by your variable on the inside of sine, and that's just 1. So here, a is equal to 1. And my formula says negative 1 p of x cosine ax. So we have this is equal to 1/2 times negative 1 times w cosine w, and then we have plus, this is the next part, well, the derivative of w is just 1. Like the derivative of p of x is just 1. So all we have is 1 times sine of x. Okay, our last step is to just substitute in our w. So originally we called w x squared. And that is our final answer here. Okay, our next example is find the integral of y squared sine of 2y dy. So looking at our table, we want to see which of these formulas matches best with what we have. And that, I believe, is numeral 3-15. Okay, and that's the polynomial times sine. So we have the following. We have polynomial times sine of ax dx is equal to negative 1 over a Okay, so the pattern is minus, plus, plus, minus, minus, plus, plus, dot, dot, dot. So that's how the pattern continues on. So why did I pick this one? Well, here, the sine part, the sine of ax, in this case a is 2. Our x, our variable here is y, and the polynomial is going to be this y squared. Okay. So let's go ahead and apply the formula here. So as I said, a is equal to 2. And so we have the following. We have negative 1 over 2 times y squared times cosine 2y plus 1 over 2 squared. The derivative of our polynomial, the derivative of y squared is just 2y. Okay, we're looking at this part. Then we have the sine of 2y plus 1 over 2 to the third. if I take the derivative of 2y, I just get 2. That's going to be times 2 times cosine of 2y. And then I'm done, because if I take the derivative of 2 in the next step, I end up getting a term of 0. So this is my answer, and again, you can simplify those fractions if you want. That would probably look better, but this is it. All right, we have 5 sine to the 4th of x, and the first thing we want to ask ourselves is which of these should we use? Well, looking at the table of integrals, it looks like we need to use numeral 4-17. And what that tells us is sine to some power of x dx is equal to negative 1 over n sine to the n minus 1 of x cosine x plus n minus 1 over n integral of sine n minus 2 of x dx. So this is what we're going to be using here. And I know that I'm using that because I have sine to the 4th of x, where we have a sine to some power of x. So I know that's a good one to use. All right, so let's go ahead and pull out that 5 first of all. Pull out that constant. And now I'm going to apply the formula. So in this case, n is the power, so n is equal to 4. So just plugging everything into my formula, I have negative 1 over 4 sine to the 4 minus 1 of x cosine x plus 4 minus 1 over 4. Right. Looks good. And then we have sine to the 4 minus 2x dx. Okay. And we have the 5 on the outside. Let's not forget about that. So we have that. Okay. All right, so let me clean this up a little bit. Just kind of cleaning up the powers, doing the subtraction. Make it look a little bit nicer. Okay. All right, so now we have to figure out this piece of information. What is the integral of sine squared of x? Well, again, we can just use what we, the same formula up here, except in this case, n is equal to 2, right? So let's go ahead and write that out. I'm going to just make some room. Make some room here. Okay. So then the 3/4 is coming out. Oh no, let's see if I made that. Okay, so what I'm replacing is, again, the right side of this formula where n is equal to 2. Okay, so we have the following. We have negative 1 over 2 sine to the 2 minus 1 x. Actually, I'll just do the subtract. Well, no, let's leave it. Cosine x plus 2 minus 1 over 2. And then we have sine of 2 minus 2x dx. All right. Here we go. Sine to the 1st of x is sine of x. Now here, this guy, what does that turn into? Well, this becomes sine to the 0 of x. Anything to the 0 is equal to just 1, right? So this is just the integral of 1 dx, which just becomes x. And then we have our plus c at the end. So that is our answer here. All right, let's do one more. We have 1 over sine to the third of 5x. So the first thing we need to do is find a suitable formula. And the one that I'm going to choose is numeral 4, number 19. And that tells me the following. I forgot the dx. Okay. Let's see. Okay. All right, so there's my formula. Now, again, just like in one of the previous problems, we want there to be a single variable. We don't want this 5x business. So what we're going to do is we're going to make a substitution right off the bat. So we're going to let w equal 5x. Therefore, dw is equal to 5 dx. Therefore, dx is equal to 1/5 dw. So this is what we're going to sub in. All right, so let's go ahead and do that. So we have, instead of 1 over sine to the third of 5x, we have 1 over sine to the third of w dw, but then we have to pull out that 1/5. Okay, so this is our problem right here that we're trying to solve. And now we can use the right side of this formula because we're in the proper form. We have a single variable, sine to the m of w. In this case, m, our power, is going to be 3. All right, so let's just use the formula. We have, maybe I'll write it out here. I have a 5th, and then according to the formula, we have -1 over m minus 1 times cosine of w, that's our variable, over sine to the 3 minus 1 of w, plus 3 minus 2 over 3 minus 1, times 1 over sine to the 3 minus 2 w dw. All right, now we can simplify this guy. So we have a 5th to -1/2 cosine w over sine squared of w plus 1/2 times 1 over sine of w dw. Okay, so we need to evaluate 1 over the sine of w, and I'm going to use a different rule for that. I'm going to use number 20. Roman numeral 4 to do this part right here. So that, let's write it out. Okay, so instead of 1 over sine W, using 20, I have 1/2 ln cosine W minus 1 over cosine W plus 1. And these are in absolute value bars. And then at the very end of this, we have a plus C, of course. Now let's go ahead and plug back my W in, 5x. So we have a fifth Okay, and that is my final answer, you guys. We can simplify it more if we want to, but this is good enough. Alright guys, thanks for watching. I'll see y'all in the next video.